Ladies and gentlemen, we've got a blizzard out today. It's absolutely flippin' gorgeous, and we're in our new studio. Hope you like it. We'll do a tour of the studio once it's totally finished. So we're spending the week talking about recycled concrete, aggregate concrete. We started off with a story time, or that might be later on, but that's what we got done the other day. And it really was a fun project for Whitney and I to start out on, and it coupled up with one of our other technologies that we've been working on for decades, or for years I should say, or decade plus. So recycled concrete, aggregate concrete, or RCAC, is where we replace a certain amount of the granular skeleton, either the coarse and fine, or just coarse aggregate, or use the whole thing with an aggregate that's been made out of old concrete. And the reason why we want to do that is, every time we use virgin aggregate, we're tearing apart either a mountainside or we're digging into the ground and tearing apart the earth. And a lot of the aggregate that we're using today is not as innocuous, or it's more susceptible to ASR and other durability mechanisms. So we really want to take advantage of that older concrete that has the better aggregate. And one of the things that we run into when we're teaching people how to use RCAC is the absorption of the aggregate. Let me define that for you. The absorption of natural or virgin aggregate is anywhere between 0.6% to 1.4%, and maybe a little bit higher. But that's really bad, really, really bad. Normally you're seeing 0.6, 0.8, maybe 1.1. The more crushed your aggregate's going to be, normally the higher the absorption. And what we mean by that is the aggregate has a certain pore structure at the surface and the subsurface that allows it to absorb a certain amount of its body weight in water. So 0.8%, if you have 10 grams, you do 0.8% times 10 grams, you get that certain amount of water that it's absorbed. The higher you go on that absorption, the more water it's going to absorb. When it comes to RCA, recycled concrete aggregate, you can have absorptions 4%, even up to 10%. And the aggregate that we use, or the RCAC that we used, had a very high absorption. And why that's a problem, why do we care, is because if we don't pre-soak that aggregate, when we put that very porous aggregate into the concrete, it's going to monopolize the water that was meant for workability, water cementitious ratio, or hydration, and we're going to see this in a reduction in slump, and maybe an increase in permeability, especially at the interfacial zone of that aggregate and the hydrated cement matrix. And again, we're assuming that we're looking at that absorption as a negative. But the point of this is not to be negative, it's to be positive and educate the industry. So imagine this is our aggregate, our German potato, our arbitrary shape in our concrete. And a virgin aggregate like this, it's not going to have as high of an absorption, it's not going to absorb as much water into the surface. But that RCA aggregate, the recycled concrete aggregate, because it's crushed, because it is a little bit Portland cement, and that does have a higher porosity to it, it is going to be able to absorb that water. And the way that we use this as an opportunity is either pre-soak the aggregate with water. And what you're doing, there's a lot of people who've written amazing papers on this, is creating an internally cured concrete mechanism. So now that we have water in the aggregate, as we mix it into the concrete, that water can be used later on to hydrate that interfacial zone and create a denser concrete, especially at that ITZ. But going a step further, what Whitney and I did is we didn't use water, we used colloidal silica and water. And we used different sizes and different types. Our research is available online for free. There's a few Medium articles that we can attach this and we can give presentations to if you'd like, we've done it in the past. But using this colloidal silica, you're going after the same concept where you're pre-soaking this colloidal silica that enhances the concrete, the hydrated cement matrix, through accelerated cement dissolution and pozzolanic reaction, will absorb into the aggregate, so that when the aggregate mixes into the concrete, one, you're not going to have the absorption of the water, and two, that water at the interface that has the alkalis in it, especially calcium hydroxide, it'll react with the silica to create more of that strength-bearing structure of concrete the calcium silicate hydrate. And we saw some great results when we combined the two. Increase in strength was okay, but it was more so the reduction in permeability, which of course leads to an increase in resistance to durability to make a concrete that is not only a little bit stronger, but it lasts a lot longer. And the biggest thing for RCAC is getting past that absorption, using it in turning an obstacle into an opportunity, and getting past the workability problems that we often see with RCAC, which is that gray concrete coming down the chute. So, hope you learned something. If you have any questions, let us know. Concrete concerns, don't forget to like and subscribe. Go concrete!
Beat asphalt!